Hello grade 11s. Today we are doing the introduction into Loci, the second part of Loci, which is the CAM. So what is a CAM? Well, a CAM is an irregular shaped disc that is attached to a shaft and turns. It has then got a follower, and this follower will move up and down, so that's reciprocating motion as the cam turns. And you then have this follower that, as it moves up and down, can do some type of motion and allow certain valves in a car, for example, that as it moves up, the other side of this will move down, and that then allows something to open, and when it moves down, it would move up on the other side here and allow something to open. You get two different types of followers. You get a wedge or knife-edged follower, and you get a roller follower. Now the big difference here is that if you have the wedge lines up with the exact point on the graph. Whereas if you've got a roller, the center of the roller lines up with the point on the graph. So there's always a slight change. Grade 11, you should be tested on the roller. The roller should be a grade 12 level. What else do you need? You need a displacement graph. So here is a displacement graph. You've got 12 segments here going up to 360 degrees. You've got a scale. So there, the scale 8 millimeters equals 30 degrees. And you should also have a vertical scale, which is usually at 1:1. This is very important. Note the follower always moves in the opposite direction as the rotation. So if the rotation here says it was turning clockwise, we would label anti-clockwise. The reason for that is it's because it is the cam that is turning and not the follower. The follower stays where it is. So as this turns, that would be the first point. If we look at the different types of motion that you can get on the follower, this one is uniform motion. So they could tell you that over 90 degrees this moves a certain distance, and you would then plot it just with a straight line. Now when it goes up, it's called the rise. If it stays still, it's called the dwell. There it rises again, and over here it falls. So this relates to the follower. So if you imagine the follower is here, there the follower is rising, there the follower is staying still, the follower rises again, and there the follower is falling. Now the different types of motions that you get. Simple harmonic motion is where your height measurements are divided along the pizza slices to plot the different points. You get uniform acceleration and retardation, where the points are plotted along equal height divisions. If you look at your circle here where you've got simple harmonic motion, the split between your pizza slices isn't equal. What happens here is that you divide your heights into equal amounts. Then the combination. So here is where you've got uniform motion, so that straight line, there was a dwell. Over here they've used simple harmonic, which is they've taken the points off the pizza slices. And on this side, they've used uniform acceleration and retardation, where you divide your heights equally. These two are metric level, so you should really just be worrying about these.